Hey guys, this is Christian, and today we're taking a complete tour of everything that I'm running in my HomeLab. Because there have been a couple of changes since the last HomeLab tour that I made around 2 years ago, so I thought it might be a good time to review everything that I've got so far with you together, starting with my current network architecture to just show you how all of the devices that I got are connected to each other. I will also go in a bit more detail on the actual equipment, so what type of components I'm using in my HomeLab, and explain why I've made certain decisions. And furthermore, even if I honestly hate to talk about that, I also have to address the biggest pain points in my HomeLab, so show you what's not working well and what is my plan to at least improve or fix it in the future. Because yeah, even though this might seem like a decent HomeLab to you, it's far from perfect, and I always have new ideas for future projects or things that I would like to improve. But let me stop talking and let's just go through it one by one. Quickly, before we do that, I'd like to highlight the sponsor of today's video, Remotely. Remotely is a remote access tool for your work and games, which is a super fast, secure, and incredibly simple way to jump into your Windows PC from anywhere. And it even lets you play games with full 4K HDR support and 60 FPS. That sounds pretty cool for all the gamers watching right now, but it is also useful for sysadmins or tech support people to control the mouse and keyboard, transfer files, or record sessions. It is super simple to use, so you just start remotely on your computer. It generates a strong connection ID that you can use to connect to this machine, which you might remember from another popular remote access software. But let me tell you, Remotely has a few unique advantages over similar applications. So first of all, it allows you to set up a private relay server that you can completely self-host in your own infrastructure. And it's also using modern protocols and hardware acceleration like HVAC encoding to make the connection really fast, secure, and efficient. And the best, for home users, it has a free tier with 1 remote session and unlimited peer-to-peer transfers in 4K resolution that you can use for both gaming and remote work as well, which is really cool. So what are you waiting for? Just download Remotely and try it out. Of course, you will find a link to it in the description of this video. Alright guys, so now let's get back to my HomeLab, and first of all I want to show you where all of the magic is happening that you see in all of my videos. So here, besides my studio, is a small room which I have to admit, apart from the HomeLab, is a complete mess, yeah, because it's mostly just used as a storage room for each and everything that doesn't have a better place somewhere at home. But yeah, just don't look at it. Yeah, better focus on my big server rack where most of my HomeLab devices and servers are located. And here you can really see all of the equipment that I've got, the cables, the servers, networking and stuff. I think I remember I built this project somewhere around 3 years ago when I routed new network cables. And I have to say it because I've seen so many other YouTubers back these days that have built these big, impressive server racks. I just wanted to have something similar like that for all of the projects and videos that I'm doing. So that's why I've got this 42-unit open frame server rack from Startech. And so far, after using this 3 years now, I can really say that was one of the best decisions that I've made for equipment in my HomeLab. And having a server rack in a HomeLab is really amazing because you can mount all of the components that you buy over time more and more of and organize them in a really professional way. And it is, of course, also super cool to have something like this at home. So when other people just show off with their impressive and expensive cars or houses, I just show some pictures of my HomeLab and then I feel good again. By the way, on the wall left of the server rack, I also have some additional devices, like a small 8-port patch panel, which is connected to one of the bigger patch panels in the server rack. So here I just mount some stuff that I need for tinkering and working that doesn't really fit in the rack. But I'll talk about the actual servers and the other components later. Before that, I want to show you my networking setup in a bit more detail, because I think this is really the foundation of every HomeLab. So one thing was really important to me when I planned a new network architecture for my HomeLab, and that was to get good hardware equipment for that. So I'm talking about a managed switch and huge patch panels and a gateway, And the reason why this was so important to me is that it gives me a lot of flexibility when creating different zones and segments of my HomeLab, which is awesome for security. But furthermore, real networking hardware also allows you to experiment with certain technologies that are often used in professional IT environments, such as VLANs, LAGs, routing protocols, things that you usually can't virtualize in a good way. And if you really want to learn these things, you just need some equipment that support these technologies. For instance, I'm running a Sophos XGS 2100 firewall as my primary gateway, through which all the traffic between the network segments passes. It does a lot of cool things like malware scanning, port and application rules, IDS and IPS, so intrusion detection and prevention, and on top it has many more enterprise-grade security features. Then I also got the Sophos CS110 switch, which connects all of the different devices in my HomeLab. It is a 24 1 gigabit Ethernet port and 4 SFP Plus port PoE switch, which is really great because then I don't need a power supply for my Raspberry Pis or the access points. And these two devices are really doing a phenomenal job. So until now, there was really no reason to change anything here. The only problem that I have is that I'm running out of SFP Plus ports because they are currently all in use for the 10 gigabit fiber optic connections between the firewall, the switch, and my Proxmox nodes and the NAS. So at some point, I have to change something about this if I want to connect my Mac Studio with 10 gigabit, which kind of would be a great thing. So maybe I just add another small aggregation switch for the 10 gigabit connections or so. I'm still waiting for Sophos to release something like that, but so far I haven't heard anything about it, so who knows when this will come out. But that might be the one and only change I'm making in the future regarding the network equipment. I also have one thing that I really never seen anywhere else. Yeah, I have one patch panel at the back of the server rack, which is connected to one row of the big patch panel at the front. I've done this because I just wanted to have a simple way to connect the cables that come from my switch to the servers in the rack, which usually have the ports on the back. And guys, I hate to route the cables from the front to the back of the server rack. It's always just a mess inside. For the 10 gigabit fiber optic cables, I still have to do it, unfortunately, but yeah, at least not for all of the copper cables. So that's why I have these two patch panels connected to each other. And of course, I also have another row of the patch panel where some cables are going down in the living room, some are going into the studio, and some other ones are going to the small 8-port patch panel that you've seen on the wall left to the rack. And to connect everything inside the server rack from the patch panels to the switch, I'm using these network cable management boxes from Patchbox, which I got from a collaboration I did around a year ago with them. And these boxes are really super useful in improving your cable management because you can just pull out the cables and they automatically roll up again when you release them. It just looks cool and it is super clean at the front, and you always have a cable with the right length available when you want to change something. That is pretty cool because, like I said, I often change things in my HomeLab. I have to admit one thing, these boxes also take up a lot of space, yeah, but for me that really has been very practical, so no issues so far, and I'm still planning to keep these patch boxes. As for the network architecture, I've created a diagram for you, and certainly also for me to keep an overview, yeah, so that it tells you exactly how all the devices that I've got are connected to each other. You can see that on the top I have my main router here, which is a Fritzbox that connects to my internet via DSL. Last year I dropped my primary internet uplink, so gateway prod 1, which was based on cable internet in favor of DSL. Honestly, the first gateway with a cable connection was a bit faster, but it was ridiculously unreliable. For whatever reason, Germany is still a disaster in terms of availability and reliability of internet, but hope is there because I've just signed a new contract because the house where I'm living in is finally going to get connected to fiber optic. At least that's what the new ISP has been telling me so far. So maybe at some day I will finally get a fast and reliable internet connection, and then I will definitely replace the old Gateway Prod 2 for DSL with a new Gateway Production 3 based on fiber. Anyway, my HomeLab doesn't really care about all of that because everything is just behind my firewall production 1. So again, this is the Sophos XGS 2100, which controls everything. And of course, I have connected this firewall to the switch with a so-called trunk port. In the past, I also used an LAG of two 10 gigabit fiber optical cables between the firewall and the switch, but because I needed one more SFP plus board on the switch for the secondary Proxmox node that I built, I just removed that LAG and I'm now using a single 10 gigabit fiber optical cable connection between the switch and the firewall. That is totally sufficient. By the way, the trunk port, this is a type of a port that carries the traffic for multiple VLANs, so virtual local area networks. Just to tell you quickly how it works, and by the way, I've explained this in my VLANs tutorial in a lot more detail. So on the firewall, I'm managing VLANs for 3 different types of zones. Like I have one VLAN for my private local area network. I have created a second VLAN for my production server network called prod. And I also have a third one called DMZ. This stands for demilitarized zone. And this is actually an isolated network layer, usually for connecting public facing services like websites that I might want to host in my HomeLab and publish to the internet. It's better to isolate these type of services from the rest of the internal network. So currently, because I don't like the idea of public facing stuff in my HomeLab, I'm not using this, but I just keep it in case I am changing my mind at some day and I want to do something with it in the future. So all of these VLANs are transported over this trunk port from the firewall to the switch, and the switch then assigns the VLANs that I want to the individual ports where the correct devices are connected to. And to make it a bit simpler for me to know which zone the actual port is connected to, I've used different colors of the patchbox cables, which is really nice in combination with the patchbox system. So blue is for the local network, green are for the uplinks, purple is for my prod network, and black is for a separate management zone that is not tied to a specific VLAN. Instead, it's using an isolated and separate port on the firewall just to have some sort of local backup connection for switch interfaces and something like that. So if we return to the network architecture diagram, you can see what type of devices are connected to the corresponding VLANs. Because my primary goal was to isolate all of my private devices like my TV, my Xbox, the Wi-Fi access points, and the private phones and laptops from the HomeLab production network, where all of the services that I'm running and testing. And because they are connected to the firewall, I can use the rules in the Sophos XG to better control what network traffic specifically is allowed to go from one segment to another. And of course, I also can apply filtering and scanning rules on this traffic. There's only one small server that is called Server Production 8, which is new, and this is connected to my private LAN. This is, by the way, the second Zima board that you might have seen. And yeah, this looks pretty new because I'm working on a new video reviewing the prototype of the Zima board too. So stay tuned for that. That's gonna be pretty cool. And this device I'm planning to use for just Home Assistant, because I had a problem with some devices like the Apple HomeKit having to be connected to the same Wi-Fi network, and to avoid having to do some complicated routing between the two VLANs, I just put this small server into the private VLAN. Then it's simpler for me to manage and it just works. But the other servers are of course connected to the production VLAN, so this is where my Proxmox cluster is running called pre-production 1 and the two nodes PRX prod 1 and 2. In this Proxmox cluster, I'm running several virtual servers with the Ubuntu Linux OS mainly, from server prod 1 to prod 6, and an LXC container for my AI workloads. The servers prod 3, 4, 5, and 6 also form a Kubernetes cluster together, which I'm actually not using anymore. I just put everything that I want to run in Kubernetes on my new Raspberry Pi cluster that I built last year, but we'll talk about this a bit later on. Then there's also my Unraid NAS, which is called NAS Prod 2, because that basically replaced my old NAS Prod 1 that I was running with TrueNAS. And then there's also another small Zima board, the server Prod 7. This small device is my primary DNS server, and I'm using it for all of the name resolutions in my entire home network. It is sometimes a good idea to have as minimal physical dependencies as possible. So if I want to restart my entire Proxmox nodes and shut down the entire server rack for whatever reason, so that's why I thought it might be a good idea to separate these type of critical services on another small power efficient device. Because it doesn't need to be fast, it just has to be power efficient and just run 24/7. By the way, if you're wondering why I don't go into too much detail about the containers, the virtual machines, the Kubernetes clusters in this video, I'm preparing a second video about my HomeLab stack. So where I talk about the operating system, the platforms, the service apps, and all of that stuff in a lot more detail. So hopefully it's going to be released 2 weeks from now. So if you don't want to miss that and you like these kind of videos, then do me a favor, hit the like button and subscribe. That would be really amazing. But yeah, so far, this is basically the entire network architecture that you've seen here. I think from a technology perspective, this is pretty close to what I've learned and saw in the IT industry when I was working as an IT service technician. Of course, on a much smaller scale, yeah, companies might have more devices. They might use other protocols and technologies like spanning tree, BGP, OSPF, and these kind of things. But still, I think I built this structure with some cool technologies like VLANs, multiple zones, enterprise-grade firewall, rules, protection, a PoE switch. So here I can basically practice and learn how to actually administer a small network environment that you would see in the industry. So that's why I put a lot of effort into building this infrastructure. Alright guys, so I know networking is a vast topic, but I think this is really so important to have a solid architecture in your HomeLab for all of the projects that you're doing. And for the server infrastructure, I kind of tried to follow the same principles. So I tried to use many technologies that you also find in the industry just for practicing, like virtualization, network-attached storage, high availability. One thing, though, that I fundamentally do different, and what you would never see in a company environment, is that I'm building all of my servers that you see in the rack myself. So all of these servers are based on regular consumer hardware. I don't use professional rack servers in my HomeLab, as you might know them from Dell, HP, and other brands. Not only because they are mostly not really power efficient, especially the older generations that you can buy for cheap money on eBay. No, my biggest problem with these professional rack server equipments are that they are extremely loud. Usually you don't care about noise in a company environment, yeah, since you typically have them all in a separate room where it doesn't matter to you. But as you can see, this room where I have my HomeLab is just right beside my studio where I'm working the entire day. I sometimes even have to leave the door open because in the attic it gets so warm here, especially in the summer. Just imagine I had some professional rack servers besides my desk where all of the fans are running at maximum speed. It would be impossible to work and certainly impossible to record YouTube videos. So that's the main reason. I honestly don't have anything against the idea of using professional server equipment for HomeLab. Yeah? It's just not practical for my situation regarding noise and power consumption. That's why I always built these servers using power-efficient, small-sized equipment with regular consumer components like desktop CPUs, non-ECC memory, and fans that are not so loud, but still have enough cooling power in the summer. And these components still provide me a decent amount of computing power for all of my workloads that I like to run the HomeLab. I mean, I don't have any super extensive computing tasks that I'm running. For what I'm doing, most of the regular desktop CPUs and motherboards are totally sufficient. For example, just take a look at the first Proxmox node that I'm running in my lab, which is called PRX Prod 1. So this machine runs in a 2-unit rack server case from Silverstone. Here I'm using a Minisorum BD770i ITX motherboard, and this has an onboard AMD Ryzen CPU with 8 cores, 16 threads, and I've used 32 gigabytes of memory. This is a fast and silent computer that is running my 2 primary production Linux VMs, Server Prod 1 and 2. So these VMs run most of the programs I use daily in my HomeLab, such as my Docker containers, the monitoring stack, the management tools, and some other applications I'm going to show you in a lot more detail in the second video. And because this is such a power-efficient server, I can just leave this on all day, all night. I never had any problems with this being too loud or consuming too much power. Regarding that type of equipment, I can just repeat what I've always said in my reviews videos about Minisorum. I really start to like this brand more and more because of their small, power-efficient and extremely powerful motherboards with onboard CPUs. By the way, if you're not into big server racks, they also have some interesting mini PCs to build a super tiny home server that fits on a desk or on a shelf. But because I've got this big server rack for all the reason I explained in the beginning, of course I want to use it, and that's the reason why I mostly have rack servers in my HomeLab, but with individual components that I built myself. And the other Proxmox node, PRX Pro 2, is also using a minis for a motherboard, but a newer version, the BD795M ATX motherboard. This has an even faster AMD Ryzen CPU and more memory. It has 64 gigabytes, and it also has a massive, powerful AMD graphics card, the Radeon 7800 XT, which I primarily use for AI workloads. So some of you might remember my last AI videos about Ollama and OpenWebUI. And this is also the node where I'm running my testing virtual machines, so the server test 1, 2, 3, 4, 5. I'm using this mostly for the experimental and testing workloads in my lab, so I don't always have this running. Sometimes I just shut it down to save some power when I'm not working. That's also one use case why I wanted to build a Proxmox cluster with one machine that is running 24/7 and another one that I just can turn on when I need it, because it allows me to do some really cool things. For example, I can quickly migrate a virtual machine from one Proxmox server to the other. Like when I'm shutting down this secondary Proxmox node, but I still need that one particular workload running, I can just migrate that over to the first one, and also my server prod 1 and 2. If I need to keep that running for whatever reason when I'm doing maintenance on the first node, I can just migrate it over to the secondary one. Of course, when you're running a 2-node Proxmox cluster, you have to have a third device, at least for quorum votes, so otherwise it just don't work. And that's another job for the small Zima board on the wall left of the rack, which does the DNS name resolution. So when I'm thinking about it, even it is such a small device, it's actually doing some really critical work. Maybe I have to move that over to another server at some point. But yeah, that's currently how the architecture works. The only problem that I currently have with this setup is, and sure, this is not a huge problem, but this Proxmox cluster is not fully high available. It's redundant because it has 2 nodes, but high availability would mean something else. It would mean if one of these Proxmox servers dies for whatever reason, that the VMs are automatically migrated and booted up on the other Proxmox node. And this is currently not working with my setup because I don't have a shared or replicated storage for the VM disks. So when I want to migrate a VM from one node to another, it first has to be copied between the nodes, which not only takes some time, but also in an outage, this would never run. Now, regarding high availability in Proxmox, there are 3 solutions that I'm currently investigating. Maybe I could add a ZFS storage pool with a replication job between the nodes, so then I could at least make the first 2 critical production VMs high available, so that they would automatically boot up on a secondary Proxmox node when the first one goes down. The second idea, I also thought about using my NAS with an iSCSI shared storage to load the VM disks from, so that they don't rely on a local storage or replication. But the main problem is that my NAS currently is not capable of doing that in a performant way. Another topic that we also need to talk about in a minute. And the third idea is I could just add a third Proxmox node and use a distributed storage with Ceph. This would allow me to make all the VMs high available, because 2 of the 3 Proxmox nodes could easily handle the additional workload. But honestly, guys, I'm not willing to invest more money and more power consumption in a third Proxmox node in my lab. I'm so happy with my 2-node Proxmox cluster, and I believe this would just be a waste of money. Even though it would be a fun and interesting project, I agree, but I'm still not convinced by this idea. I think it also wouldn't work great when I frequently want to shut down one of these servers, so adding a third Proxmox node to my HomeLab, probably not the way I want to go. So, long story short, true high availability in my HomeLab seems to be an ambitious project. Maybe the easiest solution would really be to improve my NAS setup so that I can use it as a shared storage with iSCSI for the VM disks. Which brings me to the next equipment that I need to talk about in my lab, which definitely also need further improvement, my Unraid NAS. The biggest problem that I have with this thing is the hardware specs. Because this build is not based on a minis for a motherboard, I've used an ASRock motherboard with an Intel N100 chip. And at first, this sounded like a great idea because my previous server, if some of the guys remember that project, was extremely oversized. And I just wanted to have something smaller, less power hungry than before, so I assumed using the Intel N100 was a good fit for building a NAS. But honestly, if I compare this to a a Minis Forum board that I'm using in my Proxmox server, it's not that much more power efficient. Furthermore, the much bigger problem is that the ASRock motherboard only has one M2 interface and one old PCI Express 3.0 slot and only a 1 gigabit network interface. It even has a much slower CPU compared to a Minis Forum. Looking back, I think it would have been so much better to just use another Minis Forum board, for example the BD770i, and with this I could still build a power efficient storage server with Unraid, but it would have some additional performance and some other options I could use to build a secondary NVMe storage pool for my VM disks to achieve high availability in Proxmox, or maybe I could run an additional virtual machine on this Unraid server, for example a Proxmox backup server. No, still I won't say that this entire project with the Unraid server was a terrible idea. I'm still pretty happy with choosing Unraid as the operating system because I really like the Unraid array, because this provides me a super efficient cold storage solution with all of the magnetic hard drives, which is great for storing backups and large files like my video projects and so on. But for a hot storage solution, the Unraid array is not great, so I would need another storage pool in Unraid, which you definitely can do with Unraid. So I could add a ZFS or a BTRFS pool with some fast drives, just like I've done it for the SSD caching. But I think I would have to put more drives into this pool, and having an additional PCI Express or another M2 slot on this storage server build would really be amazing. Maybe it would be a great idea to switch the motherboard that I currently have in my first Proxmox node, the BD770i, to this Unraid server, so then it would replace the ASRock board with the Intel N100 chip, and for the first Proxmox node I would just buy another Minis Forum BD795M, so the same model that I'm using in the second node. Then I have two Proxmox machines with the exact same setup, which would also be even better for achieving high availability. But yeah, these are my thoughts about changing things on the Proxmox and storage front. So there's still a lot that I can improve there, and some cool projects that I would like to do in the future. But still, be patient, you won't see these kind of videos coming out in the next time because I still need more time to research and test these scenarios. But I'm definitely working on it, so somewhere in this year I will have to make this upgrade. Alright, so I know the video is already too long, but I think we've covered most of the important hardware equipment. There's just one more thing that I quickly want to talk about, and this is the Raspberry Pi Kubernetes cluster that I'm running. And guys, this is also kind of a project that I'm really not happy with. Honestly, the more I'm thinking about this build, the more I believe doing this entire project was a mistake. Maybe I got too inspired by these other YouTubers building these crazy Raspberry Pi clusters and I wanted to have something similar. But looking back, I think that was a bad decision, because the Raspberry Pi, even the newest version 5, is really not the fastest computer in the world. If you compare this to an Intel N100, it definitely falls behind, and it also doesn't have an x86 architecture, so you're already kind of limited when it comes to container images and workloads. And furthermore, it also doesn't have a fast network connection, so when I need to take backups or I need to replicate storage, it's also kind of limited. And the entire equipment for this project, like the rack neck server case that I got to put the Raspberry Pis all side by side into the rack, is really nice. But boy, this was super expensive, yeah? I had to buy the case, I had to buy the Raspberry Pis, the NVMe drives, the PoE head, some screws and cables to mount everything, not to forget these LCD screens that I just wanted to have. Still, doing this project was a lot of fun, so I don't wholly regret it, but this project I would never do again this way, because if you really think about it, if you want to run a Kubernetes cluster at home, besides all the other projects that you need to do, I think it would be just better to run this on a few Linux VMs instead of Raspberry Pis, yeah, just like I've done it in the past, because then you would have a fast Kubernetes cluster with an x86 architecture and so on, especially when I'm planning to make the whole Proxmox infrastructure high available and so on. It just seems to be the better architecture for me. Of course, some people might argue, no, well, you could even run a few virtual machines on Kubernetes, but then honestly, the entire Proxmox setup is going in the wrong direction. So I think you have two choices here. Either stick to Proxmox, running containers in virtual machines and run Kubernetes in virtual machines, or you can go a complete different direction, forget about Proxmox, install a bare metal Kubernetes cluster on some powerful physical servers, and then start playing around with something like Harvester and so on. But I still like to keep Proxmox for so many reasons, so that's not the direction I want to go. But either way, this Raspberry Pi cluster project doesn't fit in any of these scenarios. Anyway, I'm still keeping it because I've built it, so I'll continue using it, because I already migrated some of the workloads that were running on the first Kubernetes cluster, and maybe occasionally I will do this one or another project with it in the future. But yeah, sometimes you just get a little too excited about projects like this in the first place, and in the end you just find out, well, wasn't the smartest decision. Okay guys, congratulations, you've made it to the end. Yeah, that's everything that I'm running in my HomeLab so far. And as you've heard, there are still some projects that I might want to do during this year, like achieving high availability in the Proxmox cluster, upgrading the storage server, and experimenting with Proxmox backup server. So that gives you an idea of some of the projects that I'm working on. But overall, I'm very happy with my HomeLab as it is today, and I'd love to hear your feedback about it. Please don't be so harsh to me for some of the decisions that I've made. And by the way, if you have a similar HomeLab project and you just want to share some pictures of it, then check out my Discord. I have created a separate channel where we can share our experience about our HomeLab projects, and you can see what other people in our community have accomplished by doing this wonderful hobby. So please leave me some comments below and join the Discord. And as always, thank you so much for watching. A big thanks goes out to all of the supporters, Patreon members, and YouTube channel members. You guys are really the best. You make all of this possible. And thank you so much. Of course, I'm gonna catch you in the next video. Take care. Bye bye.